difficult to do at that point have been have been simplified as time has gone by. People have different needs or different wants out of the libraries that we use. And dependency injection is a very big topic. It kind of is also a topic that a lot of people are willing to argue over. So there's a lot of opinions out there. There's a lot of considerations to think about when you're approaching this topic. So the way, because this topic is, so the way that I think about dependency injection is that we're getting to the point in our code labs where we want to think about bigger picture things. Up until now, we've kind of been discussing a lot of kind of components that you would use in an app for a particular purpose. For example, like view models and databases and kind of repositories, and all the things that we've been kind of discussing are components that you'd want to use in your application. And so creating all these components and creating kind of these modules in your application is really good for maintaining a good architecture. But you still need a way to kind of connect all these components together and also call upon these components. And dependency injection is one way of handling this particular problem. A lot of the code labs that you've kind of gone through are relatively simple applications. They're not, they don't involve too many different components. So it's kind of easy to think about these things and contain all of the things that are going on in your app in your mind. But as you kind of sort of develop out your app, complexity always kind of increases rather than decreases with an app, unless you're lucky enough to kind of be able to deprecate features. Your code base is just going to get more and more complicated. And over the past few weeks, the amount of things that you want to be able to do and how to architect that stuff has only grown. We're just kind of adding more and more things to that our app is capable of doing. You start with a simple app that basically maybe it's just an activity and it's just a fragment inside that activity and you're just displaying some information. For that kind of an app, you can kind of maintain that pretty easily and keep everything in the back of your head. Now, what happens when you start adding networking, or what if you wanted a database to start, saving your information on the hard drive, or what if you wanted to start using view models or any of the other components that we kind of are talking about? We need to, as we're using the app needs to be able to create and use these components, as we need them. We don't, the kind of naive approach to managing all of this is just create it all in the beginning. You have your application, you can just create all the things that you're going to need in your application and then just start using it. However, once you get into a few screens and a few more things and a few more capabilities, the amount of files that you have, the amount of components that you have, creating, destroying them when you need to, also, attaching them to the life cycle of your app, it all gets very complicated, and you don't want to have to do all of this stuff manually. It kind of requires, there's kind of like an overhead that you have, a cost that you kind of take when you add all that stuff in. So dependency injection is basically a way of taking all of these these components that your app is dependent on, and sort of injecting them exactly where you need them. So instead of just creating all of the things that you need in your app up front, you want to insert them exactly where they need to go. You don't want to have your view models in your repository, for example, right? You want to maintain these kind of separation of concerns. You want to basically have a well-architected app. So you'll hear a lot of things about dependency injection in the Android community. A lot of people have a lot of different opinions about them. Hilt is just one particular implementation of it, so don't think that anything that I'm telling you is kind of like gospel for dependency injection. There's a lot of different ways, and I'll kind of go over some of the other options that you might have that you might want to take a look into in the future. But yeah, today we will be looking at Hilt, which is Google's preferred kind of library for handling dependency injection. So the beginning of this code lab session, I'd like to kind of go over some of the things that that we need to think about whenever we want to implement dependency injection into our applications. I guess the first question that you should answer whenever you want to consider using dependency injection, if you go online and read a lot of things about it, people will argue to no end about what you should be doing in your app. But the thing to remember about dependency injection is you should use it when you get to a point in your app when you think that it will be helpful. If you have a very simple app and you can manage all of the components and all of the interactions, in a reasonable way without using dependency injection, you don't need it. A lot of people kind of, I would like to warn everyone up front that a lot of people feel as if you need to throw dependency injection into every app that you need. And that's really not the case. Dependency injection is a tool just like anything else when you're engineering an app. And whether or not you use that tool is a decision that you need to make and consider. It's not helpful to really just throw everything, everything in the kitchen sink at your application and think that that's going to be the way that you get to a good architecture, to get to a clean architecture, to follow solid principles. That's really not the case. So what will happen with an application when you begin? You'll create it as simply as you possibly can. Maybe you kind of throw everything into so you have an application, and then you create your first activity. Maybe you create your first fragment as well. And then the first impulse that you might have is to kind of just throw everything into that fragment. Maybe we have an app that goes out into the network, fetches some information, brings it back, displays it, and then you can manipulate that information that you see on the screen. If you have a simple app like that, you might not need dependency injection, right? So that's the first thing to consider when you're talking about this. When you want to discuss dependency injection, is whether or not your application really needs it. So keep that in mind as you're kind of going through this code lab. Is there's going to be a lot of concepts that are going to be introduced, and the best way to kind of the best way to kind of consider these things is to just kind of look at the examples that they present in this code lab and see whether or not these particular concepts apply to whatever app that you are currently looking at, in order to have a properly architected app. Now, going back to the example that I was saying before, yeah, maybe you have a very simple app that just goes to the network and fetches some information down. And if that's all it does, then your needs for dependency injection might not be quite at the level of needing a library like Hilt. You might be able to just get away with simply creating the objects that you need when you need them, and letting the life cycle of the fragment or the activity or whatever handle, disposing those objects when you're done with them. And that works perfectly fine. In that case, you do not need dependency injection. But what if you start adding a lot more screens and a lot more things onto that, right? And so now you have multiple fragments. You might have multiple view models as well. You might want to start storing information into a database, which means you need to create a database and have that accessible to your fragments as well. And so you kind of created this web of components that need to be able to communicate with each other. And that's kind of what dependency injection really is about. It's about creating a kind of a bucket that your app can go to and kind of pull out the things that it needs in order to be able to operate. That might be something like for example, if you're looking at a fragment, you might need a view model as part of that fragment. So dependency injection will be able to give that to you when you need it. Same thing if you need like a HTTP client, that's another thing that you can kind of inject into your app where you need it, right? You don't want to have your components kind of being everywhere. That's kind of what happens in the beginning when you're creating an app. You kind of dump everything into a pile, but over time you want to kind of move things out into its own components, but you want to also be able to get to those components whenever you want to be able to use them. So that's basically dependency injection in a nutshell. You just have components in your app that you need access to. And so dependency injection will kind of create that container that your application can use in order to fetch those things for you as you need them. If you guys, and feel free to stop me at any point if you want to ask a question about the things that I'm talking about. Feel free to put, I'm monitoring the chat right now. And so, yeah, anytime anything that I'm saying is kind of complicated or doesn't make a lot of sense, feel free to stop me and ask a question, because yeah, this is basically a topic which kind of covers how your app runs. So it's an important topic, but it's kind of a wide-ranging one. And like I said, there's a lot of opinions that you can find on the internet about how to do dependency injection. But if you understand the core components of what dependency injection is and what it's trying to solve, then you'll know whether or not you need to use it, or and also how to go about using a library like Hilt in order to accomplish that goal. So we have our first question. If you are interviewing a junior developer, how much do you expect them to know about dependency injection? It seems like it might not be used for most personal projects, not a lot of scalability problems. Yes, that is true. So if you're talking to a junior developer, I would say that my expectation for a junior developer is that they are aware of the topic and they are kind of aware of when to use these kind of things, but they might not necessarily have the experience of actually applying dependency injection. So for a long time, one thing that I'll say about DI and Android is that so DI has been around for a while. This is not another thing to remember about dependency injection is this is not a concept that is only applicable to Android applications. It's applicable to any sort of software engineering. So a lot of the concepts that I'm going to tell you about now are specifically for the Android environment, but a lot of the higher level concepts that you're talking about are things that that are going to show up in any sort of complicated enough software project. So yes, with a junior developer, I would expect them to be aware of dependency injection, but without having the experience of working on an app that needs to scale up to millions of users with many, many different screens, with many different components. That's where you might get a little bit less experience, but I think that's fine for a junior developer. DI is definitely DI, and being able to implement DI takes a lot of experience, and it takes a lot of kind of messing around with things. And so, yeah, a lot of if a junior developer has only worked really on personal projects, they may have never needed to implement something like use Hilt in their applications. So they might not have had a ton of experience with it. But I would also say that any sort of application at a more corporate level probably is sufficiently complicated enough that, you know, an engineer should have had some experience, at least kind of implementing it, or adding components or adding modules or whatever else to their application. Yeah, I hope that answers your question. But yeah, it is an advanced topic. And I would not expect a junior developer to sit down and do all the stuff. And a lot of and also another thing about this code lab today, when we get to it, don't feel as if you need to absorb all of the concepts immediately. It's not like with view model where you're trying to where your goal is basically to create like a view model that you can use as part of your fragment to kind of like compartmentalize the business logic. This is kind of more meta. It's more high level than that, and kind of affects the entire architecting of your application. So yeah, so what was I? Yeah, so when you get to an app that's sufficiently complicated, any sort of application, you want to use some sort of dependency injection, whether or not it's a web application, whether or not it's a mobile application, even iOS applications use some form of dependency injection, and really the best practices for doing DI is kind of dependent on whatever system you happen to be using. Android has a lot of specific sort of design considerations to think about when you are writing your app. So that's why the dependency injection is kind of structured the way that it is. But yeah, these are kind of high level concepts that you can apply to any sort of software project, not just Android ones. But we will cover this. Yeah, we will cover as much of the basic information as possible. My goal today isn't necessarily to just get you through the code lab itself, but it's also to give you kind of like a base understanding of dependency injection. There's a lot of documentation out there that you can read. A lot of it can get very technical, and you can easily get lost in the weeds. Hopefully by the end of this, you'll have a good kind of like baseline understanding of what it is that we're trying to accomplish with this. How long has DI been around? So dependency injection as a concept has been around for a very long time. If you're interested in learning about dependency injection as a concept, I would look up something called the inversion principle. It's basically kind of describing, from a theoretical point of view, what it is that we're doing, like who is responsible for creating the dependency that you need to use. So if you want to look up the principle of inversion of control, I believe it's called. Here, let me type that in. If you Google for inversion of control, this is a good place to start if you are, yes. Yeah, if you follow the link that Sagar just put in, that is probably a good place to start with looking at the more kind of theoretical aspects of dependency injection. But it's been used around for quite some time, and yeah, it's basically just a way to provide and create these components. So sort of any sort of application that has components that has these modules architected out can benefit from this kind of thing. So let's start by kind of describing what the problem is. So as your application gets a lot more complicated, you'll have these components that you're using and possibly reusing throughout your application. And if you've used object-oriented programming languages long enough, you'll notice that every sort of object kind of falls under this hierarchy of other objects. For example, like you'll start with an Android app, you'll start with your application object, right? And then underneath that, you'll probably have an activity. And underneath that activity, you'll have a fragment. And then in that fragment, you might have your data and then your views, and then maybe like a view model of some sort. You're basically building up a tree of objects, and each object belongs to another object. Now, frequently what happens in object-oriented languages when you're inheriting things, or when you have this hierarchy, sometimes you have objects that don't necessarily fit in that hierarchy in a correct way. We also have other problems in Android where famously your activity might go away, and that's and I think object-oriented languages aren't really designed to handle chunks of your app just kind of disappearing. But in Android, because of the way that it's been created, because of the way that the API works, that can happen. And so when you run into these kind of issues where your objects aren't fitting into the hierarchy in a very clean way, you want to use something like dependency injection to kind of put those components in where you need them, and have something else kind of handle that part for you. Otherwise, you'll have these situations where, for example, if you have a fragment that requires some data and a view model and a bunch of other things, you might be in a situation where you're creating all of that in that fragment each time you create that fragment. And you're going to run into a lot of issues with that, because you will manually have to manage the life cycle. If your component goes away, if your activity goes away for any reason, you might need to recover that activity, and then that would also require you to rebuild everything inside that activity. So you might take a performance hit whenever you rotate the screen, or whenever you swap out the whatever activity you're looking at. So you want to kind of avoid a lot of those issues, and you want to have something else kind of manage those problems. Are the things that I'm kind of talking about making sense to people? Yeah, if you have any questions, again, just feel free to kind of drop that in the chat, and don't be afraid to kind of like stop whatever my train of thought is, to clarify any sort of these concepts. So there's a lot of different ways that, so in the beginning, when you create your app, you kind of, whenever you create your fragment, you're going to also say, I want to create a new view model or something like that as well. So one question. Yes, Hilt is a layer that sits on top of Dagger. Hilt is basically a collection of, so in years past, for dependency injection, we've had Dagger. So we've had two versions of Dagger. Both were incompatible with each other. And also, Dagger itself ended up becoming a really complicated way of writing your dependency injection. And it kind of had a very steep learning curve, and it wasn't a very forgiving system. If you made a mistake, it could possibly take you a while to figure out what you did wrong with setting up your dependencies. So my theory is that Hilt is kind of the latest iteration of those, of trying to make it as simple as possible. And so Dagger is a code generation tool that basically would, it would do a lot of the things that we're doing today. You're going to see a lot of annotations in your code to basically tell your system, the dependency injection system what what it should do with all these components and how they're related to each other. And so, yeah, Hilt is a way of just simply annotating a lot of your objects and methods with just annotations that tell the system how to generate that code. So you can go back to using Dagger manually if you want. Hilt is just another level on top of that to just basically tell Hilt, these are the components that I want you to start managing, and also and how they relate to each other. Is Hilt Android only? I believe it is. I think it's possible to use Dagger in any sort of Java program, but I think Hilt specifically is tied a lot to Android specifically. You have a lot of Hilt kind of revolves around marking up activities and fragments, and also following the life cycle of Android itself. So I believe you can use Dagger in a more general sense, but Hilt itself is just an Android only library, as far as I can tell. I don't know if anyone's tried to migrate Hilt to, or the similar ideas of Hilt to other systems or not. Good question, though. So yeah, that brings up another good point. So a lot of the stuff that I'm talking about in Hilt isn't necessarily Hilt is Kotlin. I'm not sure what Hilt is actually written in. I think it might be. I'm not sure if it's written in Kotlin and Java or not. It could also because it's code generation. I think that it's using the annotation processor in Java to do a lot of its work. So I don't know if underneath it's just simply using Java or Kotlin. That I'm not sure. If anyone else has an idea of how that what Hilt is written in, yeah, feel free to mention that in the chat. So yeah, any other questions? Probably yes. Hilt uses Java 8 features. Yeah. So yeah, it probably uses, because it uses a lot of the annotation processing. It's probably written in Java underneath. Okay. Any other questions about dependency injection itself? Any sort of clarifications on any of the kind of things that I've been talking about? Okay. So I guess the best thing that we can do is let's start looking at this code lab. Now that you know that kind of what it is that we're trying to accomplish, let's try accomplishing that in this code lab. And so in this code lab, yeah, if you, I think Sagar included the link at the top of the chat. So if you guys want to all go into this code lab here and start going through the setup of it. So another link that I found that is very useful for talking about this, let me share a different tab here. Yes. So another good resource for kind of a lot of the things that I'm talking about. There's a more general kind of dependency injection in Android documentation that I think that might be useful for a lot of people. I think I included it at the top, but this is from the Android developer documentation. And this basically goes through some of the things that I've been talking about with as far as dependencies are concerned. It'll go through kind of like from scratch what it is that we're trying to accomplish. The example that it uses is it uses a simple car engine class, but I find that a lot of those kind of examples are a little bit too abstract. It's easier to think of it from the point of view from an Android, application, where we have all these different components that we want to kind of use it in our application. And so this page is really useful for giving you another perspective on what, how to do dependency injection and kind of where they are and how they are kind of thinking about these things. So, you'll see, like, for example, here, this dependency injection is based on inversion of control. If you wanted to dig into any of the topics that we're going to be discussing today, this is a good page to kind of start and finding out about things like these concepts that you can kind of look up on your own time, as you get to that point. So yeah, I'd highly recommend going through this page here. One of the useful things that that I found here is that once we get through this code lab, a lot of this stuff will make a lot more sense. But here you can see that they kind of go through and describe a lot of annotations that we're going to be using and when you should be using them. So when in the beginning, there's a lot of annotations that you can kind of go through and use, and it can be kind of overwhelming. So this is a good place to start to see like what it is that you actually need for any given purpose that you might need at the time. So this also goes through integrations with Jetpack components. Yeah, for example, view model is a component that you have special annotations that to do your injections here, and some of that stuff will come up during the code lab. But yeah, this cheat sheet at the end is a good kind of overview of a lot of the annotations that we'll talk about that you might want to use for your application. So I highly recommend visiting that. And if you want to learn more about Dagger itself, there's also a section down here that'll talk about Dagger and what it's kind of doing for you. One of the things very briefly, if you are not familiar with Dagger, Dagger is basically the underlying dependency injection library that Dagger will generate the code for you to a lot of the code that you would write to manually handle creating and creating objects when you need them. Dagger kind of handles that for you, and Hilt is just a way of accessing the Dagger library without having to actually touch Dagger itself, because Dagger is kind of complicated and it might be kind of difficult to read through some of the generated code that gets created. Do we need to learn Dagger before using Hilt? Not really. You can start. I think it's feasible enough to start learning Hilt annotations first, and then figuring out what the Dagger is doing later on. You will probably need to know some Dagger in order to be able to debug what you're doing, but hopefully the way that a lot of the stuff that a lot of the difficulties that existed before Hilt existed kind of go away with Hilt. So hopefully, if everything goes smoothly, you should just be able to kind of get away with learning Hilt in the beginning, and then if you need to do some debugging or really kind of dig into the weeds of this, you can kind of learn Dagger. So one piece of trivia that might be useful for thinking about this stuff is that so the reason why this library is called Dagger is because DAG stands for directed acyclical graph. And so when you look at all of your dependencies that you might need in an application, you're really looking at a graph of things. And so the directed part just means that you can only go in one direction. So if you have your chart of all your dependencies, you can only go in one direction, to resolve the object that you're looking for. The A is for acyclical, so there's no loops in it. So basically, anyone that's familiar with multiple inheritance, you can possibly get into this problem where if you're trying to resolve what object that you're trying to get from your dependency container, you might end up with a circular reference or a circular thing where one thing can resolve to two separate objects, but then that which one do you go to first? You might get the wrong one first. So it's acyclical in that it can only it'll never loop around, and it's a graph. And the G part is that it's a graph. So if you sit down and map out all of your dependencies, you will come up with a graph of how everything is related to each other. And the reason why I mentioned the graph is that if you do decide to use Hilt or any sort of dependency injection, one of the things that is a good thing to do when you want to try to use dependency injection is to take all the things, all of your objects and classes in your application and figure out what the dependencies are for them and kind of draw it out as a graph. That's kind of a good exercise to go through anyways, because it'll help you understand kind of where you have redundancies or where things can be kind of architected better. But that graph itself is what you're trying to build. And that graph is basically your pile of dependencies. And when you go into your, when you set up dependency injection, basically you're telling Dagger to generate the code that basically is this graph of your dependencies. And so later on, when we get to things like scoping, when we get to things like lifecycle, Dagger will handle all of that stuff for you. And it'll basically look things up in that graph and pull things out of it. And that's basically how dependency injection works with Dagger. It's basically a graph of things of components that your application will need, and it basically provides the management of all of those things. So at the end of the day, you are trying to solve this problem of having a lot of dependencies and a lot of components and managing all that by telling Dagger to generate this graph for you and also kind of give you your dependencies as you need them. And those dependencies are injected into whatever component that you're looking at any given time. It's an upgraded to handle to wield it better. Yes. If you're interested in learning about how the older versions of Dagger work, it's a good thing to take a look at. So yeah, if you have the time, I would recommend taking a look at some documentation for Dagger 2. You will probably, if you work on it, sort of any production app, it might be kind of like a mix of things. Some teams might be using Hilt, some teams might be using Dagger 2, some teams might be using a different tool entirely. I'll at the end of this code lab, I'll kind of mention some of those other options. I know that Kotlin has a lot of options that are available to it because Kotlin has a lot of nice kind of features in it that kind of enable you to do dependency injection in a simpler way than Java does. So yeah. Let's get started with the code lab itself. And the thing to remember if you get lost in any of this, just remember what it is that the problem that we're trying to solve and how we're solving it using this by creating this graph that is managed by Dagger that's going to be providing all the dependencies for you. So let's go back to the other CodeLab window. Hopefully, while I've been talking, this is giving you enough time to kind of go through and go through some of the setup stuff. If you haven't yet, I would start with section 2. This will give you the GitHub link to the repository that we're going to be using. There should be 2 branches in this repository. There's a main branch and a solution branch. The solution branch is what is basically the answers to all of this, and it'll contain the code that you should have once you've gone through it. So if you ever get stuck, like with the other previous code labs, you can refer to the solution and kind of use that. I would highly recommend that you kind of go through and type this stuff in manually. And if you run into an issue, then you can kind of copy paste from the solution. But the best way to kind of learn an API or learn how these annotations work and everything is kind of just go and manually type it in yourself. So I will give you guys a second to ask questions or download any of the code labs. Yes, this session is going to be recorded. So yeah, this will be uploaded to YouTube at some point. Yeah. So I'll give you guys a couple minutes to basically kind of go through to briefly read through the introduction. And this introduction will cover kind of like the basics of what I've been talking about. This part here is kind of the reason that you would want to use dependency injection, but the biggest reason is kind of you want something to manage your dependencies, and these are the benefits that you kind of get along with it, but these are kind of benefits that you would get out of having a properly well architected app anyways, especially the testing and refactoring parts of it. So yeah, let me give you all a minute or two to kind of read through the introduction real quick. If you have any questions about what they're saying in the introduction, let me know in the chat. And if you're done with that, go through and grab the code lab from the from GitHub. And if you can, try to run the main branch if possible. Let us also know if you have run into any issues with that. I wonder if there's a way in Bevy for everyone to signal if they're ready or not. If we have questions, yes, feel free to ask any sort of questions that you might run into later on in the Slack channel. If anybody here is not in the Slack for bostonandroid.slack.com, please let us know. We can send you an invite and you can come in. So I'll warn everybody up front. If you have an app that doesn't use dependency injection and you want to try and implement dependency injection, if this is your first time, it may take you a couple iterations to get everything right, because there's a lot of things to consider when you are creating these dependencies. How long you want them to live, where they're going to live, what else in your app is using them. the reason why I mentioned before about kind of creating this graph and kind of laying out all your dependencies is that exercise not only will tell you kind of how to set up your dependency injection, but it's also a good way of debugging your architecture and seeing if there's any kind of issues with how your app is architected. If you have components that are kind of repeated, or if you have components that could be be more reusable. That's kind of a good way to identify it, is to just build out the tree. Just say, okay, these are starting at the top level of your application level, kind of figuring out what components does your app need to run, and kind of lay it all out in front of you. And that that I think is probably the most useful thing that you can do before you tackle implementing dependency injection into your app. A lot of issues can actually be solved at that point in time, rather than while in the middle of kind of implementing dependency injection. Because dependency injection does kind of require your app to be kind of written in components. It doesn't. Dependency injection really doesn't work if you have an app that's kind of a single activity, and that activity just kind of does everything. Then you're already kind of doing dependency injection. You're just kind of just creating all your objects as you need them. And I'm not saying that that's wrong or anything. If that is how your app is built and it works, then that's fine. That is 100% okay. At the end of the day, having your app work is more important than having it be correct. Whatever that means. So don't feel like you need to be pressured into this. So yeah, let's hopefully everyone has had enough time to download the code. Did anyone run into sort of any issues with running this code? You may need to do so because Hilt uses Dagger, and Dagger is a code generation tool. You might, if you run into some issues with compiling your application, you might want to do like a clean and rebuild, because sometimes if the generated code gets stale, it might show up as errors in your application. And if you are trying to use Hilt and you have all of a sudden get a lot of errors and you have no idea what they could be talking about, one possibility is that you might have stale generated code that you just need to clean down. So yeah, as you're kind of going through this, and if you run into any issues, just remember to try to do a clean. Sometimes you may occasionally need to invalidate your caches and restart as well. I noticed that kind of sometimes happens when the code generation tool itself runs into some issues and just will kind of crash. You might need to do that. So yeah, as you kind of go through implementing this stuff and debugging it, just remember you might need to clean, and you might also need to invalidate your caches. Invalidating cache you might need to do very, very rarely, but it does kind of come up sometimes. So I'm guessing that everybody is kind of ready to start looking at the code and has gotten the code lab to download. So does anyone have any questions with what they're mentioning in the introduction? All right, so let's get started with section 3. So so now that we've gotten set up, and so the app that we're going to take a look at today is just basically a simple logging app. All it does is basically collect interactions that you have with the 3 buttons here, and basically just provides this log of of timestamps of when you've clicked each button. So fairly simple app. Not much to it, but so we're going to try and take some of the things that it's doing here and implementing dependency injection to get us where we need to be. So okay, so when you first load up this app, you're going to notice that there is a service locator that is handling a lot of the kind of things that we've been talking about. And service locator is another way of solving this problem that we have of being able to provide dependencies into your application. Now, we won't go too deeply into some of the issues involving service locator, but service locator is another kind of design pattern that you can implement in order to solve this. But if you would like to read about why this is an issue, I can here. There are some interesting articles that you can find about service locators and why they're a bad idea. Anyone that kind of follows clean architecture or following solid and dry principles and things like that, you might be interested in kind of looking at the reasons why some of these solutions are not a great solution. You'll also learn about what an anti-pattern is. An anti-pattern is basically like a design pattern that will cause more issues than it'll actually solve. So these are kind of some of the things that you want to avoid. But so in this case, we have this application that is written with a service locator in mind. And if you click on the link, you can kind of find out why a service locator might not be the best option for solving this problem. But basically, so this section here is describing some of the things that we've been kind of discussing. What we basically need is some sort of like a bucket that contains and manages all of the dependencies that we're going to use in our code. So this line here, it manages the graph of dependencies required to provide those instances by creating them and managing their life cycles. So just like our app has a life cycle, and all of our objects underneath it in our app also have to follow that life cycle too. We don't want to have things, kind of leaking necessarily. We want to create things that we're not actually going to be using. We want to keep everything nice and cut and dry. And so the graph of dependencies, basically the thing that Dagger is generating and managing, that is what we're trying to create right now. So this section here goes through a lot of the project setup as well. This should already be configured and done in your main branch. But if you, so we'll just quickly go over this. These are just the lines in the build Gradle and file that you want to include in order to be able to use this. So the latest Hilt version, I guess, is 2.40 right now. And you also want to include these plugins in here because these plugins are what allows the compiler to know that it needs to basically use the annotation processor to kind of generate stuff.
Excuse me.
Oh, yes. Oh?
You had lost screen share, but it just came back.
Oh, is my internet unstable? Okay.
Everything is fine now.
Okay, yes. Sorry. Might have been just a brief glitch. I don't know. It might be happening when I'm scrolling. I don't know if it's updating the video, but yeah. So these are the three main things that you want to include in your build Gradle file. And once you include your Hilt version, I would recommend also doing kind of refreshing your your libraries and refreshing that so that whenever you type in your annotations, they won't show as errors. So yeah, anytime you have an application and you want to introduce Hilt into it, include these things into your build scripts, and yeah, refresh, and then you should be ready to go. Any questions on section 3 here for adding Hilt to the project? Yeah, these are the main 3 things, and this should already be included into your main branch. So don't worry about typing this in. This is just a reference for kind of what you want to include. And yeah, the plugins here are important because that's how the compiler knows that it needs to generate the do the code generation for this. All right. All right, so let's move on to the next section here. Okay, so now that we have decided that we're going to replace Service Locator for various reasons in our application, for the first thing you want to do is you want to go into your log application class, and you will see that there is a service locator in there that we're using, and we want to slowly replace some of that stuff. And in order to let the system know that our application is using Hilt, and that it should start generating code from the annotations that we're going to put in, you need to include this annotation here for Hilt Android app. That basically just tells the system that your application is using Hilt, and it should start looking up for the dependencies and start using those annotations to kind of build out the graph. So this is pretty straightforward. Does anyone have any questions with that? Yeah, so this is an annotation. This basically, you know, is something that the compiler tends to use to kind of do different things with it. Mostly used for code generation. And if you're really interested, once you generate like some of your Hilt classes, you know, once you manage to get it to successfully compile, you know, take a peek inside. It's going to look a little strange. It does a lot of stuff with kind of you know, it's just kind of generating a lot of the boilerplate that you would generate on your own. So it's kind of, yeah, it's interesting to go in and kind of take a look at how it goes about and kind of generates those classes and what they look like. You know, they'll kind of look similar to something that you may have written, but with a lot more, I don't know, esoteric stuff that you might not want to write yourself. Basically, just like things involving managing that object. Okay, so I will give you all a minute or two to kind of just tag this application with the Hilt Android app and see if there are any issues. If in the next minute or so nobody says anything in the chat, I'll kind of assume that everyone kind of made it through okay. But I'll also give you kind of a couple minutes to try it out and you know, let us know if you have any questions. All right, so it looks like there's no issues. So let's go to the next part 4. I mean, part 5, field injection. So this is kind of where the meat of what we're trying to do kind of is. This is kind of like the basic pattern that you'll follow whenever you're trying to inject anything with using Hilt. So basically at this point, our goal is to replace this service locator that we're using in our app. And in order to do that, so we want to go through all the instances in our application where we're using the service locator and kind of swap it out with Hilt version of that. So we're going to start by going into the logs fragments, and we're going to kind of ask Hilt to create this dependency container for this logs fragment, so that all the dependencies for logs fragment can live in this container that we can pull all of our objects out of when we need them. So let's start with this here. So the first thing that you want to do is you want to tag this, you want to annotate this logs fragment with this Android entry point. Rather than thinking of it as Android entry point, it might be easier to think of it as, please create a container for me here, rather than thinking of it as an entry point, because I don't know. To me, entry point means like, this is. It sounds more like a main function, and it isn't. It's more just you're just telling Hilt to say, okay, this object here is going to have a bunch of dependencies. I want you to create something that will manage the dependencies for this fragment. So that's why we're going to include this Android entry point. And so when you do that, for every object that you want to create, or let's say for now, let's say just activities and fragment. For every activity or fragment, it's going to create its own separate bucket for all the dependencies that belong to that particular fragment. And so because we want all of our dependencies to also follow the same life cycle, that's why we kind of attach the dependency buckets to the item that's going to use it. Because when that fragment goes away, if we destroy that fragment for whatever reason, we also want to kind of get rid of all of its dependencies, because we don't want stray dependencies kind of hanging around after whatever has called them has gone away. And so that's part of kind of like the manual stuff that one would have to write if they weren't using dependency injection library like Hilt. You basically have to manage that yourself. And fortunately, Hilt makes it a lot easier by simply allowing you to annotate something with Android entry point. Okay, so once you've annotated this, logs fragment will have its own bucket. And so this note here is kind of important. So these are the kind of things that you can create like a bucket for, but there are some so there are some things that you might want to could be concerned with when you are trying to implement dependency injection with like a legacy app. So there have been many different versions of fragments over the years. Not all of them are necessarily compatible with Hilt. They are kind of separate libraries on their own. For a long time, there were support libraries that provided a fragment. There was the original fragment library. Anything that isn't the Jetpack fragment, I would kind of try to avoid using. And if you wanted to kind of use Hilt on an older app, you will need to update your fragments to use the Jetpack version of fragment instead of the deprecated versions from way back when, from like a support library. I think support v4 is one that you might run into on a legacy app. So that might be another reason that's kind of stopping one from implementing Hilt. Is basically Hilt requires you to kind of update a lot of your components to use the latest ones, and not everybody will necessarily have the ability to do that. So So that's something to consider too if you're looking to use Hilt on an older application. But otherwise, if you're using the latest libraries, you should be able to just simply kind of annotate things as you need to. So here with the Android entry point, we created a dependency container that is attached to log fragments lifecycle, and then we want to inject our dependencies into the logs fragment. So how do we accomplish that? So we have here our new bucket that gets created for us with all of our dependencies. And now we want to inject these dependencies into our fragment. So it looks like our fragment has two items. It has a data source of some sort. And if you followed along with past code labs, this is, for example, your fragment might have a view model, or as well as a link to a repository or a service or something that provides the data. Those are the types of things that your fragment will need. Your fragment depends on those things in order to run. Yeah, maybe I should have mentioned this before, but yeah, that's basically all a dependency really is. It's another object that your one object needs in order to be able to do its work, right? So in order for this fragment to display its information, it needs number one, the data, and it also looks like it needs a date formatter. So these are dependencies for this fragment that we want to inject. So that's where we get this dependency injection. So in this case, this is field injection. We want to inject these fields into this fragment. So in order to do that, we use this inject annotation to tell Hilt or Dagger really to say, hey, we want this object here. Can you provide that to me? Can you go look in your graph and see if you have an object that matches this object type? And please return that to us so that we can use it. That is in essence what we're kind of telling the system to do right now. We do that, and then that in particular is field injection because we are injecting these fields into our fragment. There are other types of injection too that we'll see, later on in this code lab. But this is basically, kind of the gist of what we want to do with everything. And so one of the things that this kind of removes, if you kind of go down to here, we have this code here that is managing a lot of the things that I was just talking about, where we have to kind of go and get that information, get those objects out manually, and we would need to write the code for them. In this example with the service locator, that's what's happening here, and that's what we're trying to replace. So I think the next instruction here is to kind of get rid of these methods because we're not going to need them anymore. And so you can see that a lot of this code that we need in order to make sure that the stuff that the logger, which is our data source, if we come up here, yeah, this is our data source, and we also need a date formatter. A lot of the code that we have here for creating that kind of goes away. And so in this fragment itself, you're less worried about kind of dealing with your dependencies, and you're more focused on the business logic itself. Well, in this case, so with the fragment, you're more worried about the view. The fragment's only concern should really be to just show your views on screen. Your view model should be concerned with the business logic of how it goes about doing that. And so you don't want to have a lot of extra stuff in your fragments. For example, managing your dependencies. And so this simplifies this fragment, and because we are getting rid of the service locator, we can also get rid of this chunk of code here, where as we attach this fragment, as we create and attach this fragment to its activity, we also need to populate fields, and we need to fetch these things from this service locator, and set the local logger and date formatter here. This just goes away. Because we are telling here that we just want Dagger and Hilt to inject these things here rather than us manually calling it. So that helps us a lot. That makes the fragment a lot easier I mean, it makes the code a lot shorter, and it makes this fragment a lot easier to read, and it also has the benefit of just simplifying things down and making sure that the fragment's only concern is to inflate the view and set all the set all the views inside to its data source. And so it kind of cleans up a lot of this kind of stuff here that we would need to do manually. Does that make sense to everybody? What it is that we are accomplishing with this. So I think the next step in this code lab is to basically just delete this code fragment here. Now, if we remove this code fragment here, then we still need to provide a way for, we still need to let Dagger and Hilt know how to create these objects as well. These objects are going to be stored and maintained in the graph, but we still need to tell Dagger how to create these objects so that later on, when something asks for a particular component to be injected in, if it doesn't already have a copy of that object created, we need to provide a constructor for it to be able to create that object. So I think the next step here that we need to do is basically tell Dagger how to create that. And so the way that we're going to do that here is by injecting the constructor in the class that we are trying to inject. So in this case here, we have two objects that we wanted to inject in. We had our data source and we had a date formatter. So in the class for the date formatter, we want to inject this constructor here. And basically, that's going to tell Dagger if we want a date formatter, and if you don't have one available in your system, this is the constructor that you should use to create it. So this line here, where we were basically pulling the object from the service locator, if you look in the service locator itself, if you dig into there, you'll see that at some point the service locator creates this logger local data store, and it also creates and it also has a method in here for providing a date formatter. Basically, if we're getting rid of this, then we still need to tell Dagger how that it should provide these dependencies to so that they can be injected. And so here we're going to simply in the class for the date formatter, we're going to inject this constructor here. And so when we come up here and we tell when we ask for this object to be injected, if it's not already available, it's going to just use the constructor that we have provided in the class definition for that class that we're trying to inject. And the same thing goes for this data source as well. We are trying to inject this data source, but in order to inject the data source, we need to construct it. And in order to construct it, we need to pass in a data access object, basically. So in this case, we need to pass in this value here into the constructor for data source, so that when it tries to create this data source, this logger here, we need a logger local data source, and it will use that constructor that we provide here to create it if it already doesn't have a copy of it. Does that make sense? Does anyone have any questions on this? This is the general pattern that you'll be kind of following when you are taking your app and kind of introducing dependency injection into it. You basically are kind of identifying the dependencies in a particular that you want to be contained, and you are providing it the way to create it. And then you're leaving the rest of the management of that, of your injected dependencies, to Dagger. Does anyone have any questions, comments, or anything like that on what's going on in this section of the code lab here? Okay. So now that we've kind of now that we've told Dagger that we want this container, and we want the dependencies for that fragment to be injected in, we can remove the code where we are creating those dependencies manually, and we are also and then we are providing the constructors for those values to Dagger to construct. So another term that you'll hear being used for this is bindings. And so this note here tells us that, so we have two bindings so far. We now know how to provide an instance of a date formatter and a logger local data source. So these here are bindings that we have created in order to provide those dependencies and inject them into the fragment where we need them. Okay, let's see if anyone has any questions. All right, if there are no more questions, let's move on to the second section. So yeah, so if you look in the service locator, then we have this logger local data source field. In this app, we only want to have one data source, right? We don't want to have multiple data sources. So this realistically is a singleton. We just want to have one copy of this data source in our application, so that any other fragment that's using this data source is consistent. It's using the same consistent data that the data source contains. So we want to kind of be able to scope some of our dependencies as well, so that we so that we don't have multiple copies of things when we don't want to. So the next section here, so moving on to the next section, we are going to basically introduce that idea of having singleton components and also scoping our components so they only live as long as we want them to, and not just having them available all the time. Because certain things you kind of want to live and die by the life cycle, and you want to be able to control. You want to be able to control when things are going to happen. Even within a fragment itself. So in order to do that, we're going to be talking about scoping. And so here is we can use annotations to scope instance containers, as Hilt can provide different containers that have different life cycles. There are different annotations to scope those to containers. And so a lot of the scopes that you'll see in this kind of match up to the components that you'll use it for. For example, like here, they talk about activity scoped. So this is, so if if you want something to be created as the activity is created and gets taken down as the activity is taken down, then you want to kind of you want to annotate those components with activity scope so that Dagger knows when to kind of do all that management work. And so here, we have that logger local data source that we were creating before, and we want to make sure that there's only one copy of that data source that we're using in that fragment dependency container. So here we're going to kind of tag this with singleton, and so now Dagger's going to know how to kind of provide that instance. It knows that it should hold on to that data source and provide that singleton anytime that you want to, that you call upon that data source. Does anyone have any questions about scoping and what that kind of means? Okay, so yeah, you can kind of look through the list of scopes and whatever else that Dagger kind of contains. But a lot of them are kind of, so the most important ones are kind of singleton and activity scoped. You'll use kind of activity scoped a lot with fragments. I mean, if you're using an application architecture where you're kind of having a kind of like a single activity, multiple fragment kind of setup, then you kind of want to scope the fragments to the activity so that if the activity ever goes down, then so does all the fragments and stuff gets cleaned up appropriately. Or you could also have a multiple activity setup too, where you have maybe you have different sections of your application. Say you have like a storefront application, right? You might have one activity that handles all the product list, product details kind of stuff, and then you might have another activity that handles all your fragments for basket and checkout. And then you'll kind of activity scope the fragments underneath each of your separate activities to that particular activity. Does that kind of make sense? What I'm saying? How you kind of want to think about this?
I was kind of wondering how it worked underneath the hood. Does it like create a table and kind of look up the table and kind of how does it all glue together magically?
If you want to dig into the weeds and kind of look at the generated code, it's basically, so it's doing a lot of the things that you would be kind of writing manually, except that it's tying itself to the life cycle of so you create a container for a fragment, rather than having to make you write all the code that basically says, oh, when this attaches or when it's on destroy, you want to clean up and do all of that stuff. It's basically kind of generating the code that does that for you. So under the hood, yeah, it's basically creating some sort of a table, and it's basically doing a lookup in that table. So when we go and look for the data source or for the date formatter, I mentioned before that this, the acyclical graph that you kind of create. So it will kind of go, graph is, Yeah, you can think of it as it technically is a graph, but it might be a little bit easier to think about it as a tree structure. So at the root node, you have your application, and then your application gets tagged with the annotation to say generate all the Hilt objects. And from there, you're going for each branch of the tree. It represents a separate scope. So you'll have probably under your application, you'll have an activity scope. And then that activity scope has a bunch of dependencies under that. And so all it's kind of just doing is it's traversing this tree or this graph, even however you want to think about it. It's traversing this. And basically, as soon as it runs into the object that you that matches the type that you want to pass in. So, for example, this logger local data source, as soon as it runs into a logger local data source that matches the type that you want, it will simply return that back to you. So under the hood, it's basically a data store that contains all these in a tree, and it will just kind of
find it.
That object to you.
So its lifetime is not the same as the activity's lifetime. It's kind of separate from it because everybody's getting the same singleton instance, right?
Yeah, but it's the same singleton instance within that scope. So
within that scope.
Yeah.
But if one activity goes away and another activity is using this singleton and then the other activity comes back, wouldn't it get the same singleton instance?
Right. So in this instance, that isn't the case because this app is simple enough that it only has a couple fragments. So it's not really sharing the data source in the way that a real more complicated app would. So realistically, like you would have so going back to the example that I did with the storefront, right? You might have a customer database, you might have a or you'll have a user profile, you'll have your basket, you'll have your products, and you'll have all kinds of information scattered through a bunch of different repositories, right? And so those repositories, you might need to, for example, on the basket, you will need to access your customer data and then the basket for that particular customer and then the product data. So you have these three repositories that you need to pull data from. So if you are sharing those kind of components, you will need to bump those up to a possibly higher level of in your application structure. And that's where, the advice that I gave before about kind of looking at your dependency graph and kind of writing it down. It's a good whiteboarding exercise to say what is being shared. It'll help you identify what's being shared across many different components. And so if that's the case, you do want to use a singleton, but you probably don't want to include the singleton as part of your fragments component, right? If it's a data source, or like say it's a repository, say you have a customer repository, a product repository, and your basket repository, if you want to be able to access all of those on the same page, you're going to have to scope your data sources differently from, say, your view model, for example, right? Your view model is probably going to be one view model per fragment, but in the case of data sources, yeah, you're right. You don't want that to be a singleton in just this fragment. You want it to probably exist at a higher level. And so this example might be a little, one thing that I'm not too happy about with these CodeLab examples is that they don't, they're a little bit contrived. And in this case, yes, this is kind of a contrived example. Honestly, this is not the kind of app that I would throw dependency injection because it's so simple. But yes, you're right. If you wanted to really think of this from the perspective of a real application, you would probably want to move this data source up a little bit higher and then access it. You would want to inject those data sources in a different way than what's being presented here. Does that kind of make sense?
Yeah, that's fine. It's just,
okay.
Yeah. Thank you.
Yeah, it's just in this example, it's just particularly really simple, so that we're not sharing this data source across a wide variety of screens. And if that was the case, that's definitely so if we took this app and kind of created that graph on a whiteboard of all of the dependencies that we want to see, in this case, you'd whiteboard it out and you'd say, okay, only this fragment seems to use this data source, so we'll keep it under there. But if it was any other app and you whiteboarded it out, you'd quickly realize that you will need to share your data sources across multiple screens, as well as other components too. This is not just extends as far as only as the regular Android components. But in that case, you would kind of see in your graph that, oh, a lot of different screens share this. We might need to kind of re-architect how we're handling that. And so not only is dependency injection like a good thing for keeping your app architected, it's also a good exercise. It kind of forces you to kind of think about your dependencies and where they should live and who should really kind of own them. That's a good question, though. Yeah, it's you can kind of as you kind of look at these examples, you can kind of identify places where things don't really make sense. Anything else? Okay, so now that we kind of understand what scoping kind of does for us in this particular instance, so I think the next thing that we want to do is, well, this constructor here that we're trying to inject, this constructor that we're providing to Dagger to provide these longer local data sources. This also has a dependency of itself. This log DAO is a dependency for the data source. The data source needs this in order to be able to kind of do its work. So then how do we, but in this case, the DAO is just an interface. It's just a data access object that we've defined somewhere. And so how do we inject that? Because the interface doesn't have a constructor that we can inject. Otherwise, we can just simply create a new dependency and say, oh, in this log DAO class, inject this constructor. But if this is an interface that we, and frequently when you are accessing your data models and your information out of the repository, your repository may be an interface in and of itself, or the service rather might be an interface and not a concrete object. So in this case, how do we tell Hilt to provide instances of this type? And so here we get into the world of modules. And so modules are used to do a similar thing with field injection, except that with field injection, we've provided a constructor because it's a concrete implementation. But with modules, you're basically, if you have an object that isn't necessarily have a concrete constructor associated with it, you want to create a module for it. And so this module, when you want Dagger to provide that particular object, you need to provide it basically instructions of what to do when that gets created. So here in Hilt, here's an example that you might want to run into, that you'll run into pretty quickly if you're using Hilt and an app that uses networking. The OKHTTP client there's no constructor for that is publicly available. You basically use the builder and feed it, the data, the pertinent data like the URLs and whatever settings you want, and it will return you the object that you're looking for that built to its particular built to that particular specification that you provided, but it's not a constructor. So how do you tell Dagger or Hilt, I want you to create this OKHTTP client and then provide that? So in order to do that, we're going to create this module. And so in this module here, I think they want you to create a new package called DI for dependency injection under the Hilt package, and then create this database module Kotlin file in that package. So this is basically where we're going to define the some of the components that we don't necessarily have constructors for, so that we can later on provide those and inject those things into objects that will need them. And so the Logger local data source is going to be scoped to the application container as we have defined it before. The log DAO also needs to be available to the application container because log DAO is a dependency on the Logger local data source. So we are going to specify that component and pass that in. So this database module is going to be defined as a singleton component because we only want one copy of the database module for our entire app. And so if we look into Service Locator, the log DAO is basically created by calling logsdatabase.logdao. That is going to return the logdao object to us, and then we use that in the service locator. But we're getting rid of the service locator, so we still need to provide how to deal with this logdao object in our Hilt component. So in order to do that, we are going to write a provides. And a provides is basically just telling the application how to basically return what object in this case where we don't have a constructor. So in this case, we want to provide this log DAO. And so we are simply, with this annotation, we are simply telling it that we want to return the database.logdao, and we're passing in this, the database object to this, and we are in return going to get back this logdao, so that when we want to inject this later on, and we want a logdao object, this provides will use this in order to provide that dependency, because we don't have a constructor for it. So so whenever you want this, it will execute this code here. So that's basically provides in a nutshell. So anytime you have a dependency that has a constructor, you can field inject it. And if you have an object that needs to be provided in that doesn't have a constructor, that uses maybe a factory or is an interface or something, you want to create a module for that. And then in that module, you want to provide a provides for each of those components. Does that kind of make sense? And you'll see a more complete example of that here, where you have this database module and you want to provide the logdao object, because that was a dependency for the Logger local data source. And then you also have this here where you want to provide the database, because here you have a database that you want to provide as a dependency. And so this will return an app database, and this will run this here. And so if you've ever created a database in using Room, you'll see that this is the exact same code that you will use. And then you are basically telling Hilt that anytime somebody wants a database of this type, this app database, then run this, and it will return this back to you, and we'll manage all that for you. So you can kind of see an example of the tree structure or graph structure here, where you have at the top level, you had, let's see if you go back. Yeah, you had this this logger local data source, which requires a log DAO, and that log DAO itself needs a database. And so you provide that chain of dependencies so that whenever you call upon that, even if you haven't created the database yet, even if you haven't created your log DAO, when you try to call your logger local data source, Dagger will go through and find its by this type here, the dependencies that you're looking for, and return them back to you using these instructors. Does that make sense to everybody? So this is, so if you don't have a constructor, basically, you need to tell Dagger what it should do in order to be able to return these objects to you. And this way, you've provided all of the dependencies that you need in order to create a logger local data source, as well as all of the dependencies in its hierarchy, so that when you call it, it has everything that it needs, and basically the scope of the data source is attached to your activity or your fragment, and so all of this will kind of be brought up and taken down as you need it. And so a lot of the boilerplate that you would have to create in order to manage that manually kind of gets handled by Hilt and Dagger. And so hopefully this is like more or less a complete example of what it is that we're trying to do in this, in this exercise here. We started off with a service locator that was kind of providing all of these things for us, but that service locator required some boilerplate that we needed to have in order to properly create and destroy these objects. Instead, now, because we're using Hilt, we're letting Hilt kind of manage a lot of that stuff for us, but we still need to provide how it should create those objects, either by creating a module that will tell it what it should run in order to return those objects, or by giving it a constructor to use to construct those objects. And so after you've done all of this, you will have replaced that portion with Hilt objects. And so in the last step here, we are basically, if you want to take a look at this down here, this is kind of how your fragment ends up looking at the end. It's really only concerned with inflating the view and managing view lifecycle stuff, and all of the code for creating and managing loggers and navigators and whatever, and date formatters and whatever else has been kind of abstracted away, and now Dagger kind of handles that. And so your fragment looks a lot cleaner and only kind of manages what you want it to manage. So yeah, that's kind of what this code lab is trying to get at. This last section here is going through binds. I'll run through this very quickly because we're running up at 9 o'clock. So binds is used to annotate an abstract function. Much like with the issue that we had with interfaces, we have no way of providing a constructor for an interface. So binds is a way to do that with abstract functions. And in this case, our navigation is kind of, our app navigator is a, an abstract function. So because we need to provide an implementation, and so if you have multiple implementations of something, and but you still want to bind, or you still want to provide that as a dependency, and you want to be able to inject that, then you want to use bind much in the same way that we did before. And so, yeah, for example, here we have this navigation module that basically contains the dependencies that we need for anything having to do with navigation. And in this, we have a bind navigator abstract function that we want to call, and so to be able to provide navigation methods, and that's attached to the activity component. So this is scoped to the activity. And so, yeah, this will return an app navigator to us, and it will kind of go out and find the appropriate implementation of that. That implementation, because that's concrete, we then have a constructor that we can kind of provide that, so that whenever we do this binds here, it will be able to kind of find an implementation of that, and also provide a dependency that you can inject in. And then, yeah, so we have this app navigator instance. So we annotate the navigator field with inject so that it gets it by Hilt manages it. Another thing to mention is that your field variables, your field injection, they can't be private. They need to be able to be visible from the outside. Otherwise, Hilt won't be able to see into it. So that's another thing to consider if you're taking a legacy app and kind of updating it. You might need to change some of your visibility in order so that Hilt can see inside your object and also inject things in. And then you can remove the navigator initialization code from onCreate, so that your new code here, your main activity, kind of looks like this. And so your main activity gets your navigator injected in, and then you can just simply use it here. You're not worried about kind of creating it or taking it down or anything else like that. So yeah, so when we come down here, this is what the navigator looks like. We've created this button fragment, and now that we've converted over the data source and the navigator, we have a fragment that only worries about the view. And yeah, and then the last thing that you can do once you've completed all this is go through and remove all of your service locator usages. And then your app should kind of be at the point where it is in the solution, where it is just using Hilt for all of this, for all of your dependency management concerns. So I hope a lot of what I have been talking about makes sense to all of you. I'm going to stop here because this is most of the basic content for implementing Hilt into an Android app. There's other things that that you can continue on with this code lab that might be interesting. There's some qualifiers here. There's a lot more controls that you can kind of put into your dependency injection in order to control certain things. Testing is also really important reason for using dependency injection. One of the benefits of using dependency injection is that if you wanted to create like a test database with some dummy data and you wanted to test against that, you can inject your test database into your test framework. And so that when you're running through your application where you would be providing the database, you would just simply tell your test framework, hey, when I want say a customer database, right? Inject this test customer database, and then you can start writing tests against the specific data in that in order to be able to verify things are working correctly. So this is a good section that you should all take a look at once you've kind of gotten more used to the other parts of implementing Hilt into your application. Yes, this entry point. This section will tell you about how to inject dependencies for everything else that you might need. For example, like content provider or like other classes in the Android system that you'd want to kind of inject. This will kind of tell you how to go about doing that. And then that should be it for the code lab, for dependency injection, for implementing Hilt. I think another thing that is good to look at too, I think Sagar included the link for Coin. So Coin is another dependency injection framework. It's simpler than Dagger and Hilt, but it uses a lot of Kotlin in the background to do a lot of its work. Part of the reason that Dagger is kind of Dagger and Hilt are kind of complicated because of the way that Java is structured. But Kotlin kind of has a lot of features in it that make a lot of that stuff easier. So Coin is another dependency injection library that kind of takes advantage of it, and the setup is a lot simpler. You kind of more or less just kind of define an array of things that you want in your application, and then you include that in, and Coin kind of handles the rest. So that's another dependency injection library that I think that represents another kind of perspective on how to implement this. And how to think about dependency injection. Both are valid. It's probably a good idea to compare and contrast the two and see if Coin is something that is easier to wrap your head around, and also if it provides a lot of the things that you need already, that might be another option. But yeah, Hilt and Dagger are they're going to be supported by Google. It's kind of the officially recommended way. So I would highly recommend taking a look at that as one of your top options for dependency injection. And that's it for the official part of this code lab. I know I've run pretty late. There's a lot of, this, as I said before, this is a very complicated topic, and there's a lot to cover, but yeah, I'll be on for another few minutes. We're also available on the Slack group if you have any other questions, if you have any other issues that you run into, because this is code generation, you might run into a weird set of errors. Feel free to post up those errors into the Slack group, and we'll try to help you debug. But I do recommend that if you do run into any sort of issues and you're not sure what's going on, you might want to try and clean and kind of do a rebuild from scratch, so it goes through and regenerates a lot of that generated code, and that might help fix your problem. But yeah, it's also a good time to take a good look at your application, its dependencies, how they relate to each other, and when you want them to be available. And then once you've kind of figured that out and get a good understanding of that, then the setting up Hilt should be a lot easier. So yeah, any questions, comments, concerns? I will be on for the next few minutes or so. And thank you everybody for joining. Thanks for putting up with my rambling description of dependency injection. Also, if you have any specific questions about dependency injection, I may be able to point you the right direction if you guys are looking for sort of a more in-depth look into this. Looks like we have one question. Wait. Question? Jake?
No, I was going to say thank you. I just turned on my mic. But thank you. Yeah, we're using Coin at work, and I'm just trying to come up to speed on that. And I'm kind of new to Android. I got a C++ background, so yeah, it's been fun.
Yeah, I'm not sure what I'm not sure what dependency injection looks like on C++ actually. Yeah, I feel like it's very different because you have access to references, so you can always kind of just pull things from wherever. Yeah, I'd be curious
Wild
to
Wild
know.
West.
Yeah, it's definitely a lot looser. It's not as tightly constrained as Java Kotlin world. So, but yeah, hopefully, the things that I've described it with dependency injection in general is kind of helpful.
Yeah, thank you.
Yeah, no problem. If we were developing 100%, yes.
Oh, Jen, I just want to say thank you as well. I really appreciate it.
Yeah,
I
no
don't know if
problem.
you can see me or not. I'm here. I'm not here.
Yeah, and
I want to say thanks. I really appreciate it.
no, thank you for joining us. I hope what I had to say was somewhat helpful.
Oh, no,
Even if you don't, even if you don't understand dependency injection, don't feel bad if you don't understand it. I mean, with anything, don't feel bad if you don't understand it immediately. These are complicated topics, and I would recommend you go in and mess around with it. Maybe not necessarily through the code lab, but there's plenty of examples online too to look through. If you just look at Dagger, Hilt, and like code templates or whatever, you'll see how other people kind of handle these things too. So
even just like being exposed to it is helpful.
Yeah, just a lot of, because there's a lot of, because this is a very complicated topic. A lot of the tutorials out there will dive right into dependency injection, kind of assuming that you understand what is going on. But yeah, it's even more at a base level. It's just a good concept to just be aware of, no matter what.
Even just hearing the vocabulary, so even hearing the discussion, like that's helpful to like build a framework. It's like, oh, this fits in here. So I appreciate it. So thanks so much.
Context. Context is always kind of helpful.
It's huge. Yeah.
I think it's pretty important for testing. We seem to be using a lot, kind of like you said earlier, substituting interfaces. But I'm just trying to get a handle on all the different annotations and where they go and what they're called and how to. I guess the plumbing.
Let me post that link up again with the cheat sheet. So this cheat sheet, I find if I had this years ago when I was learning Dagger, this would have been supremely useful because it's like, they just kind of tell you these are what the things do, but it's like if you don't have a kind of more concrete example of why you would use some of these things, and also don't feel like you need to learn all of these annotations. You're not probably going to use all of these annotations. You'll use some of them will come up pretty often, like the Hilt Android app, just to tell that Hilt that you're using this in your application. The entry point, inject. Module, provides, binds you will use, scopes you'll probably use, but like, some of the other things like entry point you might not end up running into. So just focus on the ones that like you kind of need for now and let the other ones kind of come in later as you need them.
Printing it right now.
Yeah, just kind of thumbtack that up to next to your monitor. And a lot of the kind of the things that I've been talking about, I mean, some of it is kind of rambly because this is such a kind of diverse topic. Feel free to ask any question you want about dependency injection in general in the Slack group, and we can try to kind of point you in the right direction as well. Because it is a lot. It's a lot of things to think about, especially just looking at the dependency graph alone. There's a lot of things that if you're taking an app that doesn't have dependency injection, even before you implement dependency injection, you might need to kind of modularize your app and kind of apply architectural ideas to it. If everything's just shoved into an activity, you're not going to get any benefit out of using Hilt. But if you have, kind of discrete, defined components, each doing its own particular job, then it makes a lot of sense to start thinking about this kind of stuff. Any other last questions? Yes, if you have a Kotlin, if you have 100% Kotlin app, yeah, take a look at Coin. It might be simpler and get you off the ground with dependency injection. Don't feel that because we were talking about Hilt and this code lab is using Hilt that you have to use Hilt. A lot of people have come up with really good reasons not to use Hilt, and yeah, Coin is you know, kind of encapsulates a lot of those reasons as well. Just out of curiosity, were people able to successfully get through the code lab? Did people run into some errors or issues or anything like that? Were people mostly kind of just listening in for concepts and stuff? I'm just curious if anyone managed to get it.
I was trying to get myself organized, and I wasn't sure exactly where to create the database class, where I should drop that. It kind of just like said, create the database class, and does it matter which folder it goes in? So I quickly downloaded the solution, and
yeah. If you're confused,
unless I missed it. I
think it might be. Are you talking about the section for creating the database module?
Yeah.
Yeah, it says create a new package called DI under the Hilt package, but you don't have to do that.
And then it said, yeah.
Yeah, they're just recommending a directory structure. I think that you don't have to. I mean,
at that point, I was afraid. I was afraid I was going to make a mistake, so I went and looked at the solution.
Yeah, don't worry so much about the folder structure. As long as you create this database module and you know it's in a place that you can import it in, you should be fine. As long as it's somewhere in your project.
Okay. Thanks.
Yeah, I know in the past that like especially with Dagger 2 and Dagger 1, like you had to write a lot more code. You had a lot more modules and components and things that you had to kind of write and define specifically. And so a lot of people kind of put that stuff in a particular DI folder, but if you don't need a separate folder for it, I wouldn't create one. I mean, yeah, you can kind of put it wherever you are comfortable putting it. For example, like I know that some people will structure their apps so that like each screen kind of has a folder, like each fragment has a folder, and then underneath that it has all the sub views that it needs as well as all the dependencies. You might just want to define your dependency, your fragment module in there. Right in that folder, or you can have a separate folder that contains all of it, whatever makes sense for you and your project. Completed section 5 and listened. Yeah, once you've gotten through section 5, yeah, I would say the other sections are just basically handling non-constructor based injection and how to define that. Yeah, hopefully that stuff, and hopefully the code lab covered the majority of cases that you would run into. Anything else? All right. Yeah, well, yep.
Oh, so yeah, my question about the Kotlin. If you're developing all in Kotlin for an Android, you still want to use Coin?
So I would suggest that you take a look at Coin, but the decision for which one you end up using is up to you and your team. Really, like any tool, it's not about you should use this and you should use that. It's if you need the things that Coin provides, if you need the things that Hilt provides over Coin, then yeah, you should definitely use Hilt. But if you don't need a lot of the bells and whistles, then yeah, you should probably use Coin. But that's largely a decision that you kind of need to make depending on your project and your needs. Like I said at the beginning, you also might have an app that doesn't need dependency injection at all. That's also a decision that you're going to take as well. Some people just are fine with just doing constructor dependency injection. If that's the case, then use what is suitable for your project, and don't try to over engineer things. For example, like with this code lab example, I probably would not use Hilt for something like this, but it's just an example. So take that as you will. But yes, if you do have a 100% Kotlin Android app, then I would take a good hard look at Coin and see if that kind of takes care of all of your needs. And there's always trade-offs too. Coin is a lot easier to implement, but it doesn't have as much of the bells and whistles. If you need those bells and whistles, you probably want to do Hilt. But in order to do Hilt, there's a lot of annotations that you need to go around in your code and kind of figure out as well. So.
Okay. Thanks.
Okay. Yep. If that's it, then thank you everybody for sitting through this super long code lab with me, and I'm glad that I hope that I was able to impart some knowledge upon all of you, and I am more than happy to keep this discussion going on the Slack group. So come meet us there. We will also have another one of these sessions next week. Hey Sagar, what is the topic for next week?
So the next topic would be on advanced testing strategies.
Cool. So yeah.
Yep.
So join us again next week for advanced testing strategies. Yeah. All right. Thank you very much, and
Thank you.
have a good night, everyone.
Thanks, Jen.
Thank
Thank you, guys. Good
Bye.
night.
Thank you.
And thanks,
Bye.
Jim, for leading the session.
Yep.
Thanks.
Thank you
Bye-bye.
all. Bye. Good night.